Well, hello to another episode of the podcast, and hello if you're watching on YouTube. I'm delighted to be joined by Dom Thomas today, the brains, the genius behind Fairlight Cycles. How you doing?
Hardly. I'm good, mate. I'm good, thank you. Thanks for inviting me over.
Oh, a pleasure. So the reason Dom has joined me today is to talk about a subject close to my heart and close to your heart, I know, steel.
Yeah.
And there's a saying that you've probably all heard, steel is real. So the idea of this episode is to get under the skin and what that actually means and talk about steel, your passion for it, your experience working with it, and some of what you see in the future for steel.
Yeah.
And see where it goes.
Cool.
So before we dive in, you're now working at Fairlight, but you've got a bit of experience with steel going back, haven't you?
Yeah. I co-founded Fairlight with my business partner, John. That was back in 2015, 16, somewhere around then. And then prior to that, I was hand building frames myself under the name Wold, doing sort of bespoke bikes and a few small production bikes. And before that, I was doing Genesis for 3 sort of model year seasons. So all within the world of steel, and sort of slightly different experiences. Obviously, hand making, but also being in factories in Europe, Asia, all over really. So getting a fairly broad sort of taste of the world of steel.
So you clearly have a lot of expertise and experience with steel, but why have you always worked with steel as you have and not dabbled with carbon and other materials available?
I mean, I have dabbled with other, I've done tie and aluminium at Genesis, but certainly steel was always the material that appealed to me. I guess it was just, I was drawn to it. The material, I suppose, sounds a bit deep, but the humility of it is a big part of it for me. The fact that you've got this sort of material with got such a sort of strong history, engineering and industrial history, easy to make. The material itself, I mean, it comes from the earth and from ore, and how strong it is. But yeah, this sort of beautiful material that you can easily craft. You can weld it together with just literally fire and brass if you want to. Obviously, we TIG weld, but you can braze it, and yeah, it's it can be very good value sort of on the lower end. It can also be extremely high end, pushing the boundaries of it. But yeah, it's such a really sort of humble, honest material that is incredibly strong, incredibly comfortable, durable, but you can make it light as well. It's just it sort of has that appeal, I suppose, in the way that maybe a beautiful wooden table versus a plastic table, there's something that maybe sense wise you can't really put into words, but it's to do with the material and where it comes from, I suppose, and what it can do and what it represents.
It sounds like you almost have a romantic emotional attachment to material.
There's definitely a romantic aspect of it, I would say. I mean, it's something I think about. I think part of it is informed by where you grow up and the life that you have in your sort of early years. And I grew up in Lincolnshire Wilds. There's a working landscape, so every day through the village there'd be tractors or combines or Land Rovers cruising through, and they'd all have the sort of bolts and workings on display, and that appealed to me. That sort of type of engineering, this sort of real, I suppose, tools. That they weren't in any way decorative or ornamental. They were these functional tools, and that definitely links into why I love steel. The fact that, like I say, it's this very humble material that can do amazing things, that can transport people around the world, that you can do everything from commuting to touring to whatever, just on this relatively simple machine. So yeah, but there is definitely more than a pinch of romance in there, I'd say.
I like how you describe it as a humble material. I think that's quite a nice way of putting it.
Yeah.
Because it's always amazed me. I ride steel bikes and I love steel bikes, but it's kind of crazy we do in a way, because there are better materials on paper, carbon fiber, aluminium, titanium.
Yeah.
But many of us still have this kind of connection to steel that's difficult to put into words sometimes and describe that the reason we still choose steel, an inferior material in some ways, to more advanced materials.
Yeah, I mean, I still have this. I think that if you were if you're an alien race looking down onto Earth and you came here thinking, right, we need to make this thing called a bicycle, what material do we make it from? And it's not for racing, it's for the practical purpose of having an object you can use every day, whether it's recreational, commuting, whatever. What do we make it from? I think steel still, as far as I'm concerned, stands up there because, like I say, it is easy to form. It's relatively it's recyclable. In fact, 631 and 853 that we use predominantly on our frames, the higher end steels, that's six. And this is not very well known, but 631 and 853 are entirely made from recycled steels now.
Really? I didn't know that.
They're entirely recycled.
Wow.
So the foundry that makes them recycled sources, and then it's all butted and formed in the UK. And Keith at Reynolds was telling me, I might misquote this, 30% cheaper, and also in terms of the energy that's consumed to make the materials from recycled sources versus smelting from fresh ore. Then at the end of its life, whenever that be, I think 85% of steel around the world, whether it's a car, whatever it is recycled now. So it's just, it will go back and be used for something else. I think if you add in sort of cost, reliability, recyclability, the practicality of it, it's a great material for making the sort of bikes that we like to make, which is the sort of bikes that you live with, that fit into your lives. Real bikes, not the Sunday full-on race bike, but actually the bikes that people ride and get this feeling from, and that sort of opens up this world for them.
Okay, yeah.
Yeah.
So you mentioned the difference between like racing and normal riding and utility. I know when you're at Genesis Bikes, probably going back 10 years now, you were involved in a project to put steel bikes back in the pro peloton with a team at a time. Can you elaborate on what that experience was like in terms of trying to develop a steel frame that's meeting the requirements of the pro riders who were used to carbon at the time, and how much that pushed you as an engineer and designer and push material? Did you find its limits or go beyond? Or
it was an interesting project for sure. That project really started, it was 2012, I think, but I was wanting to do a 953 road frame, and I was pitching the model year's bikes for the following year to the directors at Madison who own Genesis, and they'd always had this idea that actually they'd love to do their own race team. So this idea started up, well, actually, why don't we do something a bit different? Let's take this 953 frame and let's make a race-worthy product from it. And then I went to speak to Reynolds, and we all got excited about it in terms of what can we do with the material, and what shaping can we do with it, how thin can we go on the wall thicknesses, but we still need to pass ISO testing it. And then chatting to the vendors, the factory that we used, and getting them involved. And so it was quite an exciting project in terms of trying to make, a light, stiff, race worthy, and it won some races product, to sort of shake things up really, and to have this fresh perspective, because the UCI do have weight limits, and you can get there with a steel bike. And of course, there was rider feedback involved. There's I think it was 12 riders to begin with, and some well-established racers, Ian Bibby, Dean Downing back then, and some young guns, Alex Peters, and they all had their sort of requests. Some were easier than others. Some were literally, I'll ride anything, and but there were others that were really specific about, and also interested in it. They wanted to learn about the process, and they wanted to understand what was going to be different about it. Did we reach the limits? We were probably close certainly in terms of wall thicknesses. I think you can only go to a certain point with that before the tubes become too easy to dent, no matter how strong they are. And material strength sets that limit. I suppose there's other technologies now that maybe could affect the way the tubes are joined. At the very far end, maybe there wouldn't be practical solutions, but there may be solutions using sort of lattice structures to save a little bit of extra weight. We got pretty close with the technologies that were available at the time, and it was a great project. I certainly learned a lot from it, and definitely learnings from that feed into the work, in particular on the Strail and the Sacan, in terms of trying to make a race-worthy product, albeit slightly more functional aspect to the bikes that we make in terms of the all-season riding, but the actual bones of it is very similar. Yeah.
I actually bumped into Ian Bibby about a year ago. And asked him about.
Is he still racing?
No, he's working for a bicycle company distributor. Still riding though, still fit. But yeah, I asked him about the bikes, and he said the first one he rode was too stiff. Which you wouldn't. Still has a reputation of being springy, should we say? You wouldn't think excess stiffness would be a problem. So you had to kind of dial back the stiffness, I guess, in those early frames. And
there was, it's interesting saying that now. Thinking back, the very first run we did, the samples, I don't remember him specifically, but he made a few of the riders saying it was too stiff. As in my mind, I think the other road bike we did back then was the Equilibrium, which wasn't a race bike. And so what you're thinking is weight and stiffness. How do we get maximum stiffness? Used an 86mm BB shell, great big chainstays, 24mm. And then ovalizing the tubes and everything, and the very base of having an incredibly strong material anyway that is very stiff in itself. And it probably I think those early prototypes for some of the riders was a bit harsh, and some of the later generations we reduced the tube diameters to make it a little bit more flexible So it was a learning process, and of course those riders are all different in terms of. I'm sure they'll go on to some of them might ride a track now, and it might not be right for them. But it was like I say, it's all about knowledge and learning, and certainly I learned a lot then in terms of what makes a great bike.
I remember it quite because. The first time I steel bike, I've been using a pro peloton for 20 odd years, and like I say, won a few races. And although there's no lasting legacy now of steel bikes and the peloton, sadly, I think for a lot of people, it would change their attitude to steel. And people who maybe don't race but still want a fast, responsive bike, it may put steel back on their sort of short list of options when looking at carbon bikes and all the usual choices. And we've seen some quite interesting developments in tube set diameters and shaping and stuff. And I know you say that project informed where you are now. So you can talk about how you went from working at Genesis back in 2012 to where you are now at Fairlight, and some of the big changes you've seen and you've been involved with in terms of the shape of tubes and what's available to you as a designer and engineer.
I would say it's interesting when you look back and the way you think now and maybe the way you thought then. You look back and actually every year you're learning something new. But I would say the biggest step for me, certainly doing the Volare thing was an eye-opener in terms of, what can we do with the tubing, and having the conversations with Reynolds about shaping that perhaps previous to that project I wouldn't have had. Looking after a very large range of bikes, there was only so much you could do with each product each season. So that was quite a meaty project in terms of learning new techniques and the limits of the material. But I decided to leave Genesis and build frames. I really wanted to learn more about the nitty gritty. I just felt this strong desire to actually learn about the fabrication myself. So I spent a year doing welding and fabrication and brazing classes while I was doing Genesis in the evenings in London at a college. And obviously I had the design skills already, although you're always learning. And I just, really wanted to go away and to actually learn more about the process. And I built those frames myself. I had a fully kitted out workshop, every jig you could imagine, milling machine, lathe, all the rest of it, surface table. And, it was a hard hand-to-mouth existence for those years, but it was amazing just learning. And actually the best bit about it was looking back, was creating the processes, understanding the processes and the limits. And actually, once you'd learned, not the basics, but once you'd learned a lot of those techniques, it became quite monotonous, the work, and I didn't like that so much. But when I think about design now, and when I'm designing a product, I'm literally thinking in my head of how I'm putting that frame together if it was me. And it informs every decision you make in terms of, it's different. It's looking at an item as an object that you sort of know how it goes together, and looking at an object when you exactly know how it goes together, it completely changes the way you think about a product. And I'd say to anyone, if anyone was interested in getting into design, not just of a bike, learn how to make it. It's the best thing in terms of getting your mind working. So I took that knowledge from manufacturing, the discussions I'd had with Reynolds during that time, and actually during the time doing Wold as well. They were helping me do stuff, and yeah, they've both informed where we're at now. So actually, the way I look at a project now is every tube. I know there isn't I understand some product managers would be looking at stuff going, we've got this option, we've got this option, we've got this option. It's in a price list. This is what's available from Columbus or Reynolds. I'll look at it and go, well, okay, I see what they've got here, but I'd like to do this. It's a variation of it. I'd like to do this sort of shaping. And I'll go and have that conversation with Reynolds and we'll talk about it. And often we'll meet somewhere in the middle. But it's almost that mindset that you learn of actually there's no harm asking and checking. I suppose in some respects, there might be a fear of failure in terms of the product. If you're changing things about the product that hasn't tested, the worst thing that could happen for you as a small brand would be to have a product that had a weakness or a failure because that particular shape hadn't been used before, if you're using a very skinny seat stay or something. So you're always taking it with a pinch of salt how far you push it. But yeah, certainly now it's this sort of mindset of, right, what's the best shape for each tube? What's the best butting for each tube? And we'll literally go down to, adding 10 mil to a butt length and creating tools to do it, just to try and make, to try and get through ISO, to make the frame as light as it can be, or to have the right ride characteristics. So really focusing on the nitty gritty. And like I say, almost that visualization that actually you're making the product yourself. It just guides everything. Yeah.
So it's about understanding the limitations of the material as much as understanding how it goes together. Because I think people talk about how steel limits your options. I mean, carbon is blank canvas. You can have any shape you want and you can do this and that, a wonderful material.
Yeah.
But steel seems to have a set of limits which you can't. And it seems like what you're working on now is trying to push every part of the frame as far as possible. You're really trying to extract as much performance, but more lightness, or less weight.
I mean, there definitely is limitations, and a lot of those limitations, or the line, if you like, is the ISO test for us. So we ISO test our products, and you could debate whether the ISO test is actually beyond what a real bike would go through, but it is peace of mind.
We should probably insert now a quick explainer for what the ISO test is.
So an ISO test,
ISO
test is what used to be called EN testing. It's effectively you put each frame and fork through a series of tests, so horizontal loading, vertical loading, impact test. So it'll be putting a jig and it will go through like the horizontal test. It's being twisted 10,000 cycles. And trying to put in, I don't know, however equivalent years of riding that is, and then it'll have to do a vertical test. Then they'll crash it into I'll drop it from a height, which is the impact test. And so you have all these different tests to get through to certify that the frame is safe. And we're a direct to consumer brand. We sell all over the world. We sell quite a lot into the US now, and it's quite important, particularly for that market, that we're covered. With the sort of litigation and all the rest of it, that we have a good and strong and safe product. But also for ourselves, for myself and John, we don't ever end up in prison for corporate manslaughter. So you want to make a safe product. I'm not saying that bikes that aren't tested aren't safe, but it just gives it that approval that actually it has met. So that, I suppose, is your line that you
That's your limits, isn't it?
Is your limits. And I've designed a lot of different bikes now over the years and put them through testing. A lot of frames have, for example, the new Strail failed a couple of times and we had to change. The frame would look identical to your eyes. It was the length of the butt inside the tubes to try and get it to go through the test, and it went through the test. So it's these small differences. So now I'd look at a test and I can almost tell you how long a butt needs to be for a certain test. A road ISO test is different to a mountain one. Right, the butt needs to be this long. If it's 853, the wall thickness needs to be 0.7 or 0.8, depending what test it is. If it's not that, we're going to struggle. Or we could go with a thinner wall but make the butt longer. So I've already got a very clear sense of where my starting point is, and then I'll try and usually err on the lighter side. I'll try and get close to it, and like I said, it may take one or two tests to get through it. We'll always get through it, but we're trying to hover around that line to try and push the limits. And also Keith and Dave and the guys at Reynolds are very, they have a lot of customers and they have a good sense themselves of those lines as well. So between us, we can talk about it, and they know what we're trying to achieve, and they'll help me get there in terms of tooling or whatever to make the butts longer, or to create a bigger diameter tube, or with the same butts or something. So designing steel bike is not rocket science. It really isn't. It's quite simple actually. But it's like with everything, it's this sort of hard-earned knowledge that I could write it all down in pages and pages and pages of it, and you go, hey, this is a guide how to make a steel frame, and you'd absorb it and get it, but you still wouldn't have all that knowledge that's built up and the way you think about it. So it's, like I say, it's not rocket science, but you learn as you go, and you keep pushing those, you keep pushing yourself, I suppose, to try and do things a little bit more. But we're talking small increments, not huge gains now because of where we're already at and having to pass these tests.
I think some people might be surprised how much you are pushing the limits with material that a lot of people might perceive as not having changed much since the Eddie Merckx days in terms of tube sets available.
Yeah.
But it sounds like you are pushing the limits as much as a designer of a carbon frame pushes the limits in terms of weight and wall thickness and stuff. So it sounds like you're at the limit. How close to limits, or kind of how many more possibilities are there to change a butting on a tube, or do you think are we at peak kind of steel frame?
I think we probably are. We're probably close to where we could go with it. There may be other things we can do with butting depending what type of bike it is. But we're not really in the realms where we can remove 200 or 300 grams, or even probably 150 grams is a struggle, because you still have to get through these tests. And material like 853 is already a very, very hard material. Once you go harder than 853, you start working into difficulty with the forming of that material. The cost goes right up because of tooling wear and all the rest of it. And actually the price for the customer is going up significantly, but they're not getting a huge benefit. They may be saving 100 grams. And, at the heart of the products we make is this idea, despite the fact we're talking about the technology, is we want these bikes to be sort of accessible to people. We want to sell them in volume, not just because we're trying to make money, but because we want people to ride our bikes. We want bums on seats. We think it can improve lives. And that's a big part of the job. Hearing back people saying, this is the best bike I've ridden. I love it. I ride it every day. That's a massive part of it. And price is an issue within that. You don't want to. So it's trying to get that balance of making it technologically as good as it can be, but also that's part of the challenge. How can we make it for a certain price so that it's not £3,000 because you might sell 5 of them, versus £1,299 for our frame, or £2,899 for an all-Tegra bike, which I think is amazing value for the work that we put into it. So yeah, we want it to be an accessible product that isn't just a statement of design. I mean, it is a statement of design, but it's also an everyday person can go out and buy it if they're in the market for it. So that factors into it as well. And that's also interesting because trying to achieve the pricing in terms of that also affects how you design stuff when you're looking at materials and how you join the materials of braze or TIG, or when we're making the dropouts, we're trying to make something beautiful. We're also trying to go back to this sort of when I was making frames, how do we make it? How do we make it so we can make it using the technologies that exist in these facilities? Or we can create some of our own tools, but we still need to rely on their skills. So it's not just an abstract object that looks pretty. It's something we can actually make in the real world, but that still looks pretty because we go to the extra thing of making it look beautiful. So yeah, it's don't know where I've got to, but yeah, if you sort of get me, it's this combination of trying to make something great, but also trying to make something accessible as well.
You seem to be talking with attention to detail you expect from a kind of bespoke custom frame builder, making a one-off frame, but you're building on a reasonable scale now.
Yeah, we are. Yeah,
not a small company, not a large company, sort of mid-sized company.
yeah,
There aren't many brands offering sort of attention to detail in a product at a reasonable price.
yeah.
That Fairlight is.
No, I mean, I would agree with that. I mean, there are others. I think there's others doing good products, but yeah, that's certainly something that we're aware of. Is this sort of and it is a mindset. Let's try and push this, and I will, take it home with me a lot of the time in my head. I'll carry it around, probably to the point where it's not healthy. It's this obsession about this when I'm designing a new bike, and when I start getting absolutely sick of it, I usually think, well, I need to draw a line to it now and say that's done. But it's almost this idea that when someone's buying your product and they're paying a lot of money for it, that when they get that product, they can sort of sense that this care and thoughtfulness that you've put into it. They look at it and all this tube, like when you got yours, and you looked at all the tube shaping that you'd only seen in maybe I don't know if you'd reviewed it, but you'd seen it in a catalogue. But the same when you see it in the flesh, you can see, God, look at all these shapes. Like, they must do something. This isn't just for that they can see it's an engineered object. And we get so many nice emails from people, the beautiful details, the frame ride's great. And, you feel good that you've sold a product to people that you've put so much work into, that you haven't just created something and put a price and a nice colour, that actually in your heart what they're riding is this really great product that is going to, hopefully make them feel great every day. So that is a part of it. You're not just doing it for you, you're doing it for the people that are buying the product.
Yeah, I know personally the details on the frame are what drew me to it, and it's an interesting one because there's a lot of work goes into the carbon frame. I mean, they're really complex to make.
Yeah.
But with a steel frame, especially like the Fairlights, all the details are clearly visible. The shape, the crimping of the tubing, all the little details are there. You can see all the engineering, the thought that's gone onto it. It's not hidden away underneath the paint and the carbon. It's there on show. And I think that appeals to people.
Yeah.
You clearly tapped into a healthy kind of niche of people who want that sort of high-end steel.
Yeah.
Reasonably priced. Often than that sort of 4-season riding, and ride quality is first and foremost, isn't it? Yeah,
I mean, it's just what you're saying there about the difference between carbon and steel, and the fact that almost there's this expectation with carbon that everything has to be seamless, hidden, and that's just the way it is, and that's what customers want. And I kind of get that, because I suppose the very nature of the carbon material, it's almost got this F1 type appeal. It's the super light, super stiff, sleek, and going back to when I was talking about steel and why I love it so much, and this being informed by growing up and beautiful Land Rovers and tractors and stuff, everything's on show.
Get misty-eyed now, aren't you?
Yeah, nuts and bolts. I just really like that when you do look at a bike, you can see everything and you can kind of understand how it's gone together. And of course, it's welded tubes. Everyone can see, okay, well, they're welded tubes together, but when you see a tube in a certain direction, you can, even if you don't know anything about it, you can, sort of in engineering, you can understand that, okay, if that's wide there, I'm guessing it's stiff there.
Funny because a carbon frame is still handmade like a steel frame, but it's like all the engineering on a carbon frame is hidden inside in it. So it's almost like a steel frame, a carbon frame turned inside out, so you can see all that, the quality of the welds.
Exactly. So it's all on display.
Yes,
it's all on display. So you can't hide any of the fabrication. It's all there to see. And we were, definitely my taste is for, cables on the outside and everything fixable. Because you're adding complexity if you're running cables through the frame. Often it is, unless it's for area benefits, which don't really come into our world. It's for the visual, which is fine. Aesthetic is a thing, and that's cool. But, I just like this idea that you can easily fix things. If you see something wrong, you can pull it off, put it back on, see it, understand it, and get back on the road and ride your bike. It's this, again, come back to this idea of it being a tool. Tools, not trophies, that it's this thing that you go out and ride and makes you feel better. But it's each to their own, certain people like the sort of seamless vibe, and that's cool. And others like the sort of more, I suppose, utilitarian. I'm surprised I haven't mentioned that word yet. Yeah, that's definitely what I like, and goes hand in hand with the material. And this, that everything's on show, the material itself, the practicality, and all the rest of it.
Something else I want to ask you about is going back to the 80s when when steel was still a popular option.
Yeah.
The sticker from the tubing supplier, whether Reynolds, Columbus,
Yeah.
was as important as the brand name on a down tube, so 853.
Yeah.
For example, how important is that today with modern tubing developments? Is 853 still important selling point or market quality for you? Or
is it a selling point? Definitely, it's a selling point. The heritage has a value, and people recognise that badge. For me, it's important that we have the 853 badge on the frame because of the relationship that we have with Reynolds. I've worked with them for a long time. We talked about the Volare project at Genesis, and they're heavily involved in it. So they're always, if I'm asked starting for example, designing the Strail 3, there's a lot of toing and froing in terms of what can we do, and they want it to be a success as well because they see it as a sort of one of not the only but a flagship for their brand, and it's collaborative. The ideas that I have, I'm informed by them as well in terms of what they can do with the material. Same with Mark Bentley, who does all the dropouts. They're a huge important part of what we do, this collaboration. And it is a collaborative product. I have this sort of almost this sole vision for the products, and I'm bringing it together. But I'm reliant on them in terms of guiding what can be done in the real world. So, how can we machine this object practically? Do we need a 5-axis mill, or how can we make it to a price and still make it look beautiful? So Mark will guide on that, and the guys at Reynolds will guide on how we can make this tube. So yeah, it's a badge of quality, but also for us, it's almost a badge of collaboration as well. That we can we have this amazing fortune that we can work with a UK-based company who have probably more butting and forming experience than any other steel tube company in the world. Going back, I don't want to misquote Keith Patel, but 850 years, whatever it is, something crazy. From when they were first butting tubes. So it's an amazing thing to be able to tap into, and they're always willing to help. So is it important? Yes, and certainly it carries a value as well for the customer. 853 is 853, the heritage of it. You talk about Eddie Merckx. I'm sure there's been hundreds of bikes that have toured the world in 853 as well. So it's a badge of quality, but these things are hard earned. So it's earned the right to be more expensive, more premium because of everything it's done. Yeah.
I've always been curious about the relationship between a frame builder, designer like yourself, and the tubing supplier.
Yeah.
I mean, what comes first? Do they develop a tube set and go to a frame builder, or do you say I want a tube that does this and they try and develop it, or is it bit of both? Or
no, I mean it's we haven't we've never sort of made a new material, so the chemistry of the steel we're not that far into it. We don't that's something that would be a step too far, if you like. So quite quickly you'll be thinking, well, this is an 853 product or a 631 product or 725 or whatever, or 953. And once I know which material is the right material for that product, it's then talking to Reynolds about the shaping, about the butting, how do we actually make it, how do we form it, and then some of the forming might not be done there, might be done in the vendor. Okay. So with the chainstays, the Strail 3, which I know you talked about when you reviewed it, the forming tools for getting that beautiful flattening, that's done in the factory, not at Reynolds. So but it's it'd be nice one day to be able to create, a new tube set,
signature tube set,
and have our own
Dom Thomas,
have our own have our own signature tube chemistry. Don't think it'll ever happen.
Tube sets don't come along that often, do they? Not like buses. I mean, 853,
no, they
953 was
it
must be 10 years ago. We've not had anything since.
Yeah.
We'll get onto some future tech in a bit, 3D printing and other stuff. There's one story I want you to tell the listeners, and
Yeah.
you told me when you dropped off this trail about the developments behind the chainstay. I know this is super geeky, but I'm sure people appreciate the detail, the lengths you went to create something that is. Because the chainstays on that bike are unlike any other chainstay I've seen on a steel bike before, curvy in the way that carbon is.
Yeah, I mean, it was one of the when we're doing the Strail 3, the Strail 2 is already and still is an amazing. It's a great product, even if I do say so myself. It's a great product, an amazing product, and it was really difficult. We were already, down to sort of 0.4 mil wall thicknesses. We'd done the best we could with the shaping, with the biol down tube, the flat oval, very skinny top tube, and was really struggling with what's the plan of action for this Strail 3? How do I make it even better? And it was sort of there was the making a new fork, so we opened new tools, and we created our own mold for the fork, so we own that mold. You won't see any other bike apart from a Fairlight. And we changed the butting slightly on the down tube to make it stronger because it's now compatible with slightly bigger tyres. But the main thing was the chainstays, forming, shaping them so that we had, vertical compliance, lateral stiffness. Like you say, this almost, a few people have compared it to sort of the old CADs, like this sort of the CAD chainstays, very, very flat, almost hydroformed looking stays. And we still wanted to use Reynolds. So we, it was something we couldn't do in the UK. I was chatting to the guys at Reynolds, Tom, actually, after when I was visiting them a short while ago to talk about a new project. And they said that when they saw the lookbook, they were even scratching their heads thinking, right, what process did they make that? Did they do this bend first, that bend first? And they were thinking about it in the methods that they would form tubes. But yeah, the way we did it was effectively a CNC'd mold, if you like, so shaped as the tube looks, and it's pressed, hydraulically pressed into the shape. So the dimples are all in there, and everything's in these tools. We pay a cost up front for the tooling. And other brands do use the tooling, but not typically for to do the style of shaping that we would have done. So we paid a lot of money to open these forming tools, and the tubes go in before heat treatment. They're shaped, and then they go off for heat treatment as that forming, can stress the product, potentially lead to fatigue. So we have to increase strength afterwards. So it goes through heat treatment to add strength. And also the very thin 0.8, 0.6 is a butted stay. Typically on, mass production frames, you generally got plain gauge rear ends. We very lightweight butted rear ends in our frame. So yeah, it was costly, but it was something that we just wanted to do, again, to improve the product, take it this step further. So, the weight isn't any different for that tube than the old version. And actually the tube size is the same. But if you look at them side by side, you can see in the lookbook, the design notes, the shape's just drastically different. And when I first got the sample, I was back-to-back testing just on local roads, just over a day, just trying to feel the difference. And I could feel it straight away, just this sort of comfort. It's difficult. I always find things that are difficult with words are very... words can make jump sound like a lot. It was stiffer. It was flexier. Sometimes when you're riding, it's just this very small perceptive thing. You get a sense for it, and usually that sense is right. This feels a bit comfier, and it is a bit comfier. It might not be, it's not a huge amount different, but actually over the course of a ride, it will be, and especially over an ultra endurance race or something, it all helps. So again, it's just this idea of, let's just keep evolving the product. And, if you look at the work and the effort and the money that we put into just those small things, that actually the man on the street's just seeing an 853 badge, I think, well, it's madness, but we believe it's the right thing. And it's actually the reason why we do the design notes, because we've got this story to tell. And even they really only touch the sides. There's quite a general way that we lay it out. There's so much work that goes into trying to make this great product. So that was it was a good one, because obviously the reviews came out from yourself and other publications, and everyone thought it rode great, and it does ride great. So yeah, in that instance, it was worth it.
It's a lot of effort to go to, isn't it? For some people, might think it's a chainstay.
Yeah.
And I guess you had no idea it would offer better ride quality over the previous one until you rode it. So by that point, you put a lot of money down to develop the tube set. And
the maths doesn't lie. So I mean,
okay.
the
so you knew it could be a smooth ride.
I mean, we hadn't CAD engineered it, but the maths, you knew if it's flatter and wider, it should be more comfortable and stiffer. And we maintained the round section for a longer distance near the bottom bracket. You can just look at them and think, well, okay, this is gonna be more resistant to pedaling forces than this one, and it should be comfier too. I can imagine how that's going to move, and so it was just a case of, this is the right thing to do. Let's do it, and let's make sure we tell the story of why we've done it. And yeah, it'll be, and it was worth it. It's a great product, and the the struggle now is trying to think of a Trail 4, which we're not onto yet, but it will be difficult to improve on it.
Yeah, I'm just amazed at the effort you've gone to, because like you say, you touched on it just now, trying to describe how something rides compared to the old product is difficult to put into words, because when you say it's better, we're talking about maybe small margins of improvement rather than big drastic leap forward. And there must be something inside you that drives you and motivates you to develop a chainstay like that, and you have a feature on the frame that really, you could have Trail 2, very good bike, happy days, but you've gone even further and above and beyond what might be expected of you. I mean, what's driving you inside to push the limits of steel and push the frame?
I think you sort of, in some ways, you create a rod for your own back, because when we first launched, we tried to make some great frames, and we did design notes, and we had great reviews, and that sort of sets a precedent of where you're at. And obviously there was a lot of obsessive time and effort that went into those products, and that's continuing. I suppose it's a mindset. You're always trying to improve. Again, going back to this idea that you appreciate people are spending money on your product, you want it to be the very best it can be. And there's also this knowing that, like I say, there's a lot of brands, I certainly won't name any, but I think a lot of brands, even within steel, they have a single product manager looking after a large range of products, and there's so much they can do each year to these bikes, and they have to meet price points, and they simply haven't got the resource or the time to really focus in like we can focus in, and that's really our model. How do we make this the best it can be for this price? How do we really go at it? And all that experience, like I said, from making frames and doing frames in the past, it all feeds in. But ultimately, it's about, let's just make this great product that when people ride, they're going to be amazed by it, and they're going to really, like I say, it's going to make them feel better. So it's sort of this. You don't ever want to get to this point where you just expectation people are just going to buy stuff because they've heard your name. You always want to be trying to push and push and push, and also it's kind of addictive, this process of trying to think of little improvements. You get into this thought path that you get a bit obsessed by it, and it's exciting that always really clear. One of the sort of things in the design process is this moment where you have a picture in your head of the product, roughly. I've got it. Okay, I can see it now, and you get this really excited about it. I've got the idea in my head. I can see the dropouts. I can see the tubes. I can see the shaping. If we bring this out, we're going to do really well with it. And that excitement gets you through the whole project. And sometimes you'll lose the vision during the process because, you can't do this or you can't do that. And maybe before you know it, it's changed slightly, but you have to look back and think, that was the vision for it. That's what I was excited about. And if you're excited about it, the customer will be excited about it, because ultimately I'm a consumer too, and you're sort of making bikes you want to ride yourself, that if you saw, you'd think, wow, that's an amazing product. So if you can look at it like that, hopefully the customer's thinking that as well.
Okay.
Yeah.
In terms of pushing the limits, that seems to be a theme so far. You're pushing the limits of steel, and it sounds like you're pretty close to the limits. Where do you see the next big innovation coming? I know Reynolds particularly are working in 3D printing parts.
Yeah.
And we're seeing some brands incorporating 3D into probably less so with steel but other materials.
Yeah.
Do you see any scope down that 3D printing avenue for you as a brand, or a designer, an engineer to?
I'm not sure. I mean, I should just say when I don't come across in the wrong way when I say sort of pushing the limits. We are pushing the limits
In a good way.
In a good way,
an exciting way.
But there are, like I said, with 3D printing, with other things where they are pushing the limits in terms of the absolute technology. But obviously, they'll be very, very expensive, and they might only sell one of them or 5 of them. We're trying to push the limits within, at the same time, make a product we can mass produce and get people on the bikes. But that is also a fun part of it, that you're trying to make this product that is accessible, and that they set the limits. And, you know, as technologies come through, they become cheaper, I suppose. So at the moment, 3D printing is very expensive. I think 3D printing is interesting as a technology, and obviously we're seeing it being used a lot in the custom world. Tom Sturdy doing incredible work with titanium and tie bars, tie forks, and, you know, beautiful stuff. And I saw Quirk at Bespoke had done a 3D printed steel hardtail, again, really lovely. But these products are incredibly expensive, and that's fine because that's the world they exist in. It's the custom world. People are going to pay for it. And for me, because of everything I've said about, you know, my tastes and sort of this idea of utility, at the moment it doesn't sort of marry up with the sort of products I want to make, because it is very it's very expensive. And, you know, I think there's a good story behind 3D printing in terms of the simplicity of it. In the customer's eyes, they think, oh, okay, I get that. The builder can just cut the tube and then this lugs do all the work, and it's easy to understand. But actually, you know, lugs were around for a long time, and lugs sort of did the same thing. And actually, with what we do with TIG welding tube, that's still very simple. You know, they have machines to cut the tubes, to miter the tubes correctly, and then they have, you know, amazing welders to join them. You're still only joining the tubes. I suppose with 3D printing, you're getting this seamless look that is more akin to perhaps what we'd expect from carbon. It's almost the look of this sort of molded object rather than a welded object. And that's an interesting aesthetic. I don't particularly think you're getting anything in terms of the ride quality of the product. Although saying that you could maybe do things around the BB in terms of forming that area. Again, so what am I saying? I'm saying it's an interesting technology. I'm saying at the moment it's too expensive for us to consider for anything other than maybe a small part that would help us in a particular area of the bike. But yeah, I don't think anytime soon we'll be bringing out a 3D printed bike. It would be an interesting concept as a product. You know, it talks about maybe how would the idea of like honeycomb lattice structures and with no cover to try and really reduce the weight. And Reynolds did an interesting product a few years ago at a show where it was a titanium frame and they had these lattice BB area, the seat tube, the head tube, and it was incredibly light. You'd look at it going, actually, I can see practical issues with that, you know, mud getting onto it, and obviously it'd be very, very expensive. But it's interesting as a idea, and ideas are really important. So we'll keep our eyes on it. I think at the moment it doesn't really appeal in terms of the types of products we're trying to make. It's just too expensive, but never say never. As the technology develops, there may be ways that it becomes more accessible, where we feel it's worth making a bike from it. So yeah.
So it's about utilising that new technology where you see it offers a benefit to you, the brand, in terms of pricing and an actual functional benefit, not just for the sake of it looking nicer and prettier.
Exactly. I think there's an element of it where, you know, it's aesthetically beautiful. I can certainly see for custom builders, you know, like Tom Sturdy, like Rob Quirk, where they're able to offer this point of difference and engineer different areas of the bike specifically for the customer, for these single frames. And I think that's great, and they'll do good business from that, and they deserve good business from that because, you know, they're exploring these areas. For us, you know, trying to mass produce bikes, trying to make them accessible, it's still, on the fringes too much. It's still too expensive. But like I said, we'll keep our eyes on it, and there may be small areas where we can utilise it in the design, or there may not be. But it certainly wouldn't be for aesthetic reasons, I don't think. It would more be if it was the best method for that particular job, in terms of weight or in terms of the type of shape of the object. Obviously, you're limited by CNC for certain objects. You can't really make it hollow unless it's a tube and you're sort of drilling it out. So, yeah, and obviously we use 3D printed plastic parts for cable guides, where for that particular application, there's actually the best material and the best technology for that part, because we can make it at a certain cost, and the 3D printed material has a little bit of malleability to it, so it fits into the hole and it expands a little bit, whereas metal would be too rigid or a bit rattly. So as per the 3D printing of the plastic parts and the dynamo mounts, we do the same. There may be an opportunity in the future where, as price comes down, we start considering the metal parts, steel, tie, whatever it may be. But yeah, it's something to keep an eye on.
Okay. Given we went back 10 years a little while ago to your Genesis days in 2012, can you get your crystal ball out and see where you and the brand will be in 10 years' time? Or where steel? Do you think? Because steel seems to be it's always been a popular material. It seems to be more popular now.
Yeah.
I don't know if it's a backlash against carbon or the environmental stance, or there's more knowledge. Or do you find yourself still have to justify steel in a world of carbon and bikes? Or
I mean, I'd say for our existing customer base, we don't have to justify it. We're still relatively small, although we are growing. But there'll always be the sort of the customer who maybe is newer into it, or just ignorant because they associate steel with weight, and how has steel still got a place in modern cycling? And obviously it has, for all the reasons I said. And certainly when I look at us in the future, we'll continue to make these great bikes like the Strail, like the Sacan at the higher end, but we're also looking to move into products that are even more accessible, tools for getting around town. And I won't touch on what, because we're really in the early stages, but it's something we're looking at in terms of making the product more accessible, where steel is still so relevant because of the recyclability and reliability and the cost of making it, comfort and all the rest of it. So it's still very much in our plans going forward. And it's still, as I can tell, it's incredibly relevant as a material, and will be for a long time. There's always going to be people that want to buy a frame to do all types of riding on, that's going to last them for 50 years. Although they probably won't ride it for 50 years, but the intention of it doing so, and to do lots of different types of riding on, and steel will always be great for that type of customer. And we're looking at other areas as well. So where will we be in 10 years? Hopefully still making great products, hopefully still enjoying it, growing, making more bikes, getting more people on our bikes, contributing to society, but there's certainly a lot to get through. It's challenging enough now, just with lead times we were talking about it before. I mean, it's unbelievable, how far ahead we're having to order just to sort of keep up with the demand that COVID has created across the industry. Having to get our little bit of the pie and get in with the factories, booking years ahead just so we can keep going with it. It's exciting. Maybe in 10 years we will have a 3D printed bike. I don't know. And we may look at the materials. Like I said, I've done aluminium bikes in the past. I don't think we'll do them at Fairlight, but never say never. Tie
seems a natural fit for a brand like yourself, because it's similar to steel.
Yeah, I mean,
a bit lighter.
Exactly. Yeah, it's a similar material, and I think it has a similar customer base. So that is perhaps something we'll look at doing. So yeah, it's, and I'd love to do, or we'd love to do. I speak for John as well. Things like cargo bikes and things like that. These sort of everyday bikes that
Very hip.
we're hip,
right
yeah.
now.
But again, it's just I'm
But cool. I'm joking though.
Yeah, no, but
it's.
I keep saying with this idea that the bikes that people ride day to day, that actually probably is the bike in your stable that you get the most use out of. That, and for a lot of people, you might have a fleet of beautiful bikes, but it might be the steel single speed that you ride every day that's the one you really love riding, or the Sacan or whatever that you go out on the farm tracks.
The pub bike.
The pub bike, yeah, but those bikes are a sort of value that you kind of get attached to them, and they're arguably the one that sort of has the biggest effect on people's lives, because they're using it to get around. They're not getting in a car or whatever. They're getting around this bike. So, utility, practicality, obviously important words to me and to the brand. There's all sorts of areas we're excited to go into in the future. Certainly people shouldn't expect one to be in the market tomorrow or a year or even 2 years, because we're still, exploring ideas, but also just trying to keep up with the day to day. But I'm excited. I'm excited by it. We're excited by it. Where we can go with the brand, and we feel we've really focused on the right things. We've built strong foundations. We've focused on quality. We try and give good customer service. We try and always do the right thing, and that's the mindset we'll continue with, and we'll just see where it takes us.
Okay. Well, I think we covered a lot. I think there's more we could cover. And we're not really talking about how it rides and springy ride quality, but we'll say that for another episode. I think that's a good place to leave it there. So
Cool.
Thanks so much for
no problem. Thanks
joining me on the podcast. Hopefully you all enjoyed it. Well,
nice one.
see you again soon.
Cheers, Dave. Thank you.
Should we go to the pub?
Yeah, let's do it.